CIT 1124, Module 11, Submodule 2, Mitigating VLAN Attacks. Let's take a look at the single slide that we have here for mitigating VLAN attacks. We've got 5 steps listed here, and they're all good. First one is disabling DTP. DTP is the really cool, fun trunking protocol that we like, that we can just go ahead and just do switch port mode trunk, and it's turned up, and we don't have to build a domain or add a password. It just works, and it's cool that it just works. On the other side of that, that's a little insecure. So instead of having our interfaces auto trunk for DTP, we're going to go ahead and remove that. Switch port mode access will take away the ability for an interface to be in auto trunking mode. So we talked about that in the last slide. Step 2, disable the unused ports. We talked about that in the last section also. Manually enable trunk links on trunk ports by using just the switch port mode trunk command. As you know, there's a couple of different. There's dynamic desirable, and there's some other commands we can use with our trunking modes. Dynamic desirable and auto specifically, we don't need to use those. Just use switch port mode trunk. That turns it up. That means that interface is going to be turned on for trunking, and you don't have to worry about negotiating, because the next line that you're going to type in is switch port non-negotiate, which says that, look, it's on, and if the other side that you're connecting to is also on, the trunk port is going to work. And if the other side is not set to switch port mode trunk, then it will not work, and there will be no negotiation. So they take that really cool negotiation thing, and they're like, hey, if it's dynamic desirable to dynamic desirable, or dynamic desirable to auto, and don't worry about that stuff anymore. Just turn it all off, and if you want to turn trunking on, just do switch port mode trunk. And if you want to make it secure, do switch port mode trunk, and then do switch port non-negotiate right after that. The last step, step 5, is go ahead and changing the native VLAN. Now, we've talked about the native VLAN a lot. One of the things with the native VLAN is that it is not tagged. Traffic from the native VLAN is not tagged as it moves from switch to switch or from switch to router. So that could be information that comes from any place. Anyone that has no idea of what your VLAN setup looks like could possibly pass traffic across the native VLAN, because it would just be traffic that's untagged. And if it's allowed to pass along the system, they've now decided that untagged traffic is bad, and we want to go ahead and just get rid of that. So first of all, the main thing that they want you to do is take the native VLAN from VLAN 1 and put it on a different VLAN altogether. And then don't run any traffic across that VLAN. Basically, just leave it as a dead VLAN, so that you can change that native VLAN to something other than VLAN 1, and then don't use it for any data at all. So you're basically mitigating all of the native traffic. So anything that passes from switch to switch across the trunk should be identified under the VLANs that are available, and you can specify specifically the trunks that you can use. So you can do the allowed VLANs, and then just not allow the native VLAN across that trunk link. That'll effectively block any native VLAN traffic that could go across there. All right, good. Next attack we're going to talk about are mitigating DHCP attacks. This is some new information for the CCNA. This is not in the older version. And one of the things that you can do with your routers and switches is you can check for rogue DHCP servers that may be out on your internet or on your network. And this is, they had a few slides in the PowerPoint. If you go back and you look at the whole thing, there's about 3-4 slides. I think this one kind of just rolls it all down into a nutshell. So what we've got here is we've got a diagram with a PC and a switch and a DHCP server. This DHCP server is a trusted server. This is the server that you want to use that's going to pass the correct DHCP IP addresses out to your clients. It is not a rogue server. So it's a regular server, and it's posted there, and it goes into interface F0/1. So what we're going to do is we're going to go ahead and trust that interface by adding that command ipdhcp snoop trust. You can see that there. It's a different color of marker because you can't see that at all. But right there. ipdhcp snooping trust. We're going to go ahead and trust that interface. And interface range is 5 through 24. We're going to go IP DHCP snooping limit rate 6. We're going to go ahead and set that limit rate to 6 packets per second for DHCP, and then we'll set that per VLAN as well, and that'll lock down our system from any rogue DHCP messages that might appear across our system. The next slide is a show IP DHCP snooping, and it shows that it's enabled here, and you can see the bindings between the interfaces and the MAC addresses and saying, okay, this one's going to be okay. We're going to be able to use this. This particular interface has a legitimate DHCP server on it, and we'll allow that one. The next attacks are ARP attacks. And ARP attacks are kind of hard to stop because once you get into the LAN, broadcast messages are going to be spread, and ARPing is a broadcast message. It starts as a broadcast, and you don't really know who's really sending from where. So the thing that you've got that will help you out is something called dynamic ARP inspection, and this is also new to this version of the CCNA. And what it's going to do is it's going to identify devices that are using ARP in an a non-normal way, and they do a nice job of checking that here. So the DAI to check your ARP cheaters, you're going to enable DHCP spoofing, and then enable this as well, and it'll configure trusted interface for DHCP snooping and for ARP inspection, and it'll just basically check to see, hey, you know what? Should you be allowed to get information from one device to another? And the answer may be no, that you don't want some devices to communicate with each other. So what we can do is we can set trusted and untrusted ports for ARP resolution. Also, gratuitous ARPs constantly being passed onto the network from an interface. They're going to go ahead and identify that type of traffic as well. So for instance, what would be a good way to find all the IP addresses that are out on a network? Because you don't, maybe just join the network and you don't really know, and you kind of want to find out. One of the easiest things you could do is just start sending gratuitous ARPs out and say, hey, everybody on the network, this is 192.168.10.1. I'd like to join your network. Does anybody else happen to be that? And then waits for the response back from 10.1 and goes, okay, that's definitely that's definitely a device in this network, and I now have that device's MAC address. And then you gratuitous ARP as 192.168.10.2. Hey, I'm 10.2. I'd like to join your network. If anybody else already has that address, please let me know. And so on and so forth. And you can go from 1 through 254, and you'll be able to identify and map out absolutely every single device on that network. Think about all the great information you could get that way. You could get the MAC address of every single device. You'd have the mapping to their IP addresses. And you would have the manufacturer of their network interface cards, which would then give you insight into what each one of those devices actually is. So that's a lot of good information that you can get by just, spoofing some gratuitous ARP packets out onto the network. So that's one of the things that we want to go ahead and turn that off. We don't want that to happen. So IP ARP inspection trust is going to be the command that we're going to use on a trusted interface that is going to be able to set for as the uplink port for the router for ARPing. It'll also keep other devices from pretending they're the default gateway on the network. Okay, cool. And the next type of attack we're going to look at are STP attacks, or spanning tree protocol attacks. And in these types of attacks, we could have a bad actor that could join the spanning tree network and maybe change who the root bridge is and gain access into the network that way. So one of the things you want to do is to prevent devices or switches or fake switches or bad actors from joining your network is you're going to go to every one of your access ports that's connected to end devices, or truly connected into a jack that's connected into a place where your end devices are at, and you're going to set up two different commands on those. You're going to set up port fast, and you're going to set up something called BPDU guard. When you set up port fast says this: We're not going to check to see if this is a switch on the other side. It's supposed to be an access device. So we're going to skip the whole listening and learning and blocking states and go directly into the forwarding state for that particular interface. The second thing you're going to do is this, is you're going to set up what's called BPDU guard. So if you happen to set up an interface and you set up port fast and you skip and you go directly into forwarding, and that could create a loop, the way you can stop that loop from happening, or in this case, the idea is stop a bad actor from gaining access into your switching fabric, is you're going to use BPDU guard, which is Bridge Protocol Data Unit Guard, which just basically says this, is if the receiving device on the other side starts sending BPDUs to you, then your switch will then just turn that interface off because it's supposed to be an access switch. So what someone could do to try and gain access into their network is plug a switch into a port that should be an access port, but maybe it's not set up as port fast, and it doesn't have BPDU guard. It could join that STP network. To stop that from happening, set it to port fast and set up BPDU guard, because BPDU guard is going to tell if that's a switch on the other side, and if it is, it's going to disable its own port. That's what they're getting into there. And you can just see the command here for port fast and setting port fast as a default. Port fast would be something you definitely don't want to use on your trunk links, but you do want to use on your access ports. Same thing with BPDU guard. I think we've got that covered.